Hi all, welcome to day 8 of our 100 days of DevOps journey. So today was it was a long day for me, some crucial task at workplace, so couldn't get much time today. So let's just start quickly with where we have left. Yesterday we have discussed about Git, what is Git, okay. Now let's discuss about GitHub, what is GitHub, okay. GitHub or any remote repository. So first of all, recap on yesterday's task. What are the commands that we have learned here is git status we have learned, okay. Git add file. We'll check git reset. Git reset is basically some git reset is a critical command. If not used with caution, it might cause you your code, your progress. So we'll check it when to use, okay. Then git diff we have seen, git diff stage. So diff on what stage but not yet committed. So there are a lot of things, but I would suggest you, since sometimes CLI is very good, good to have CLI. I am also very fond of CLI itself, okay. But sometimes CLI might not suffice the need, so you can also use the GUI. I use VS Code. In that there is one plugin called Git Graph, okay. I'll show you that extension, Git Graph. So it is very handy when it comes, so when it comes to compare or anything. So this particular version, it is very smooth. It is so I use it very much, and I recommend it strongly. So you can just check it, Git Graph. It is an excellent plugin that can be used, that any coder can use, okay. Now today let's start with our day 8. So where did it go? I have installed a lot of plugins right now, so my VS Code is like uh, it is huge, okay. So git diff, I didn't see very much. Git diff I don't use very much. I use this particular when it comes to graph. Otherwise I'll just check it on if required. Git diff can provide git diff hyphen h. You can see there are multiple options that are available. So there is one option that will provide you with all the changes. So diff stat instead of patch, name only, status only, full index, so full object name, index line, okay. So these are some of the important then swap, detect, limit name, reorder, output patch format, output diff raw. So multiple things here we can see. Treat all files as text. So let's just begin with today's task. Let me just open my draw.io. It is also one of the tools that I use for flowchart and diagram making. So it is very handy when we require it. So let's just understand what is local repository and what is remote repository. First of all, repository is basically where you have your code, container image, or any other data that is crucial that you stash, okay. So anything is any storage of data, crucial data, can be considered as repository, okay. So suppose it is your local system. Let's just say, yeah, it is local machine. It is a local machine. So you have your in this, what do you have? In this machine you have data. Wait a minute. Text. In this you have your project, okay. This particular, this is your project uh, that has been available in your local machine. I'll just put it in here, it would be much better, okay. So, okay, here this is your project, a git project, we can say a local git project. So you have everything, you have committed all the data and everything over here. But what might happen sometimes, sometimes it might get damaged. Okay, it might get like, where did it go? Yeah, sometimes what might happen, it get uh, damaged, this particular system. So, and your hard drive is corrupted. So what will you do? What can you do in such situations? So you might lose all of your code. So it is a good practice to create, suppose there is, so this is an enterprise environment. Okay, it is not over the internet. So what you can do, you can share it over a network, share the data over a network, network of computers or something like that. So maybe in your colleagues system or something. Okay, or there is a server. We have configured a local and on-site server. Okay, on-site Git server. So this is not this is nothing but a storage. Okay, so this Git server, what will it do? This particular Git server, it has all your data, and it can share it over the network. Okay, this is your complete network in here, and this server has multiple other this server has multiple other connections, so you can have different replicas, developer 1, developer 2, developer 3. Okay, all of them are connected to this server. Oh, sorry. Okay, so all of them are connected to this server. So this is how this will be called as a remote repository. This particular server here, this server would be called as a remote repository for these systems. Okay, these systems, it could be considered as remote repository. So we can fetch and backup the data like that. And what if this server also gets crashed? This server also gets crashed. So all of them might lose their data. So in such cases, what happens? There are some services. So over the internet, okay, yeah. So over the internet, what does people do? People just store their data on such remote repositories. Okay, so I'll just, okay, so they just keep all their data on on some of the services. So some of online platforms. So what platforms do we have here? GitHub we have. Okay, GitHub we have on online. Then there is GitLab. GitLab is also very popular. I'll just add text over here. GitLab, we have GitHub. Let me just increase it. Yeah, GitHub, GitLab, then Bitbucket, Altation Bitbucket, and there is then cloud native service. Some of the cloud native services like Code Commit, AWS Code Commit. We have seen the example. Okay, AWS Code Commit, Azure Repos. So there are multiple different options on cloud. And on cloud, what they do is, we'll understand some basics of cloud in our journey, but I'll just brief you about it. So in cloud, there is one term called high availability. Okay, one principle on which cloud thrives. It is high availability. So uh, on demand and highly available. So cloud is mostly on demand and highly available. So all these services are, all these platforms are hosted on some cloud services. So we can anytime we can fetch our data from them. Okay, so it is over the internet. So that's how remote repositories are stored. Remote repositories work. Okay, so this is just the theory how remote repository is basically. So they'll keep this project part, this project thing over the internet with them. This over the internet on their infrastructure. Okay, and it is secure. Okay, everything is encrypted and all. So your code, until you make it public, it won't allow anyone to check your code. So this is how it is. and you can check it all that. So Git project you can host over and multiple projects. Suppose you don't have to care about your storage or anything. You can host multiple projects on this cloud storage, cloud repository. It is called the remote repository. So now just check how we can access the remote repository. So yeah, git init, git clone. First of all, let me just create one repository, any random repository for you guys. I just go to github.com. First contribution. It is this first contribution is also a good repository. It is just to let you know how to make commits, how to do open source contributions. So you can use this. What I'll do is I don't have an account. Okay, no problem. I'll create one. Welcome to GitHub. Enter your email to be. Okay, we already have this email. No worries with that. Oh, I think I forgot my password. Let me check if I can. I got the code. Okay, so here we have there are some of the repos. Let's just create one project. Day 8. Okay, I'll create one project. Day 8. Day 8.0. I think I have some important thing to show you guys. So here you can see public, private, then readme file. If you add a readme file, then your repo would be initiated automatically by GitHub. So first, let's just initiate everything. Initiate the repo and create a repo. Okay, this is day 8. Then how can I access this? There are 3 methods. So GitHub CLI for Windows users and others. SSH is also very reliable, and most of the enterprises and other use SSH for their local machine. HTTPS is a public method for accessing. So let's just go over there. I'll go back to day 8. So this is how I double dot is for. So let's just recall. Double dot is for parent directory. So I went back to 2 folders. So here you can see day 7. I'm creating another folder, mkdir day 8. Okay, this is day 8, cd day 8. Oh, sorry, day 8. Okay, right now nothing is in this folder. So what we can do here is this command, git clone. Git clone is one of the very handy command. You can directly clone. It means download. It will create a clone in your local system. So local git clone, and then you have to paste the URL that you have got. Okay. Now if I can see, day 8 has been here. Okay, day 8.1 is in here. Suppose if I have suppose I have to create another repo. I already have created a repo in my local system, mkdir day 8.1. This repo I have created. Okay, cd. How would I create a repo in my local system? So yesterday we have seen. So where is ls-a? What is happening? So right now there is nothing in this repo, but if I just run git init, so I'll initiate my repo. Okay, then how would I access? How would I configure this repo to my remote repository? So there is one method. So with the same name, or name is not important over here, this day 8.1, but it is a best practice to keep the repo name same as your local repo. Okay, so I just go back to my account, create a new repo. Where did it go? Repositories. New repo, day 8.1, public repo. Then I don't want to initiate this. Okay, so I'm not clicking anywhere. Initialize this repository, no, and create repo. So it will provide us with some instructions. Echo this. So these are the commands you have to run in your local system. So echo, it will create. What is happening in my system? I'm not able to. Yeah. So a readme file has been created. If I check git status, so untracked file, one new untracked file is created. Git init we already have done. And then git add readme. I just git add readme.md. Press tabs when you want to run the autocomplete in Linux. So it will make your work even faster. So we have committed everything. Now these changes, if I just check readme file, okay, day 1, this is for branch initiation, git branch. So I have capital M is to default branch, to set the default branch. Okay, here you can also see here they have used a small branch, but capital M is for setting up the default branch. If I just check git branch, so only main is available. Let's just confirm git branch -h, and here you can see, yeah, move, oh, rename a branch. Okay, rename for capital, and small m for move rename branch reflow and it's reflow. So rename a branch, so we have renamed master to main. Okay, now git remote. So git remote, what does this option do? So it manages the remote repository. Git remote, here what are we doing here is git remote add. We are adding a remote repository. Okay, remote host, then remote add. This origin is the name. Okay, origin is the variable name, and this is the variable value. If you are familiar with coding, so you might understand this. So origin is just a empty box, name of an empty box in which we are placing this URL. Okay, I can place I can add any name, but origin is by default is a default configuration for GitHub repository. So if you just enter git push, so it by default push to the origin. Okay, it by default push to the origin. It does not ask you for where to push or what is the remote address. So origin we keep like that. Okay, we have now added the origin, and git push origin main. Main is the branch. This -u is to set up the upstream. Upstream is like to where this code is going. Okay, to where this code going. So git push upstream origin main. So origin, this particular URL, because it is not very convenient to all the time enter this URL. So origin and main. Okay, so it is a public repo. So right now nothing is in this particular repository. What is it saying? Allow. Let it allow. So I have if we can see here, this account has been set up. Okay, I was earlier using this account. Now this account has been set up. So all the changes that I have made over in my local repository, if I just refresh it, you can see. Okay, so who has made the commit, you can see over here, Harishankar Dubey, name. Okay, name of the user is here. Okay, so that's how you can manage your code in remote repository. And same for git push. If I make any change, okay, suppose I go back to here and add a file, create a new, I can create a new file over here. Hi, this is Hari. Okay, name of the file intro.txt. Commit changes. Without commit, you are not able to save anything in this file. So create intro.txt I have created. If you want to enter some description, then you should enter in big enterprise and MNCs. So you should enter the description. They probably have a template for their own commit a commit template for that. But yeah, we can directly commit it in here. So what can we do here is, so right now if I just check, so git graph, sorry, git log. So it will say enumerate and everything. Yeah, there is one more command, git fetch. So what does git fetch do? First of all, let's just understand that git fetch is basically it will check if there is any commit. It just check your current branch is in line with your remote branch. Okay, your local repository is in line with your remote repository. So that's how git fetch works. So if I check git fetch, so it will check, yeah, remote enumerate 4 done. This is counting object. These are the 4 objects, compressing total 3, delta 0, reused, unpacking. So yeah, this is the commit. Okay, origin main. So this is local commit. If you can see over here, I think let's just refer to our document there. Where did it go? Yeah, yesterday we have seen git log, git merge, git checkout, git branch. Okay, and git branch, git status, git add, diff we have seen, git commit we have seen. Okay, now today we have seen git clone, git init. Git config we also have seen yesterday. Then going back to Git show human readable format, show an object in Git diff. So these are all use cases of Git merge we have seen. Git push we have seen today. Git fetch down all the branches from that remote repository. All the branches it fetches. Okay, what are the different branches? So if I just check in my Git graph, unable to. What is happening over here? Okay, I think there are multiple remotes in this. So okay, no issues with this. Username has changed. Git graph. Let me recheck. There is no commit in the repository. It is 100 days of DevOps. Okay. So it is checking 100 days of DevOps. Then there is, yeah, my repository. Here you can see one more repository we have added in here. It is in day 8. Okay. So you can select the repository. I think it hasn't detected my repo right now. Okay, no worries with this. So here we are. So we can check over here, over there. So where were we? Yeah. So Git fetch fetches all the branches from the Git. Okay. These are some of the very basic questions that are asked by interviewers. Okay. What is difference between Git fetch and Git pull? So Git fetch fetches the branch. Okay. Git pull fetch and merge any commits from the tracking remote branch. Okay. Suppose there are the changes that we have made, and here there is some data that shows the discrepancy. Okay. Git pull. If we run Git pull, so this file, one file change, one insertion, create mode, this intro.txt. Okay, fast forward is one of the merging method. We'll understand later on what are different merging method over here is. So if I run git fetch, it won't show anything because everything which is available remotely is now in our local machine. Okay, all the branches that are available remotely are now in our local machine. So that's how git fetch and git pull works. Git pull fetches. Git pull does two jobs. Okay, it fetches and merges, fetches the remote data and merges it with our local data. So that's how git fetch and git pull works. Then yeah, git rm, git mv, git log, these are some of the temporary commits. Git stash, sometimes it is very useful. Git stash and git it is also asked what is the difference between git stash and git commit. So you might be, git stash is just for temporary commit. Suppose you are working on two different feature and they have their separate feature branches. So right now you haven't tested one of suppose feature 1, you are working on feature 1 as well as feature 2. You haven't tested in your local machine. Whenever you run your code, you keep it like you also run it in your local system. Okay, in your local system for testing how it is working. So if you haven't tested it, or there are some of the changes which might you haven't completed all the changes and you have to switch to another branch. Okay, in that case, what will you do? You'll just stash your changes in your current branch in like feature 1 and jump to feature 2. Okay, so those changes could not be propagated to the remote repository and you can continue where you have left. So trash pop, git stash list, git stash pop, right working from top to stash tag, and discard the changes. So if you don't want to use those changes, then you can stash it. So that's how. So it is very minimalistic cheat sheet you can use, and in Git it is more like process, more like the practice that you follow rather than the commands. Okay, if you can go to for various commands, you can anyway use this git -h. So it will show you all the commands that is available: clone, init, then add, move, restore, remove, bisect, diff, grep, log, show, status. There are a lot of then there is chroma, branch, commit, merge, rebase, reset, switch, tag. Tag is very important command. We'll see. Tag is basically whenever you want to release release a particular version of your software, you think it is working well, so tag it. It is a good practice to tag your commit. Fetch, pull, push. So there are not much command in this. Only the practice that what practice you follow. Okay, what process do you follow? That's how you can make Git a very powerful tool. So we'll understand that. Let's just see. There is one thing that I want to show you guys. So suppose we are right now in Git. Okay, this is a brief intro today. So I'm also exhausted. We might continue tomorrow. So let's just go over here. So right now we are in root directory types. Okay. There is build your own. I'll show you some of the repositories. Build your own. Okay, build your own X. This code crafters IO. Build your own radar. Build your own. So just build your own X. It is a public repository, and you can use it for various to learn various things. Like if I have to, yeah, 3D render and augmented reality, BitTorrent client. You have to create BitTorrent client, blockchain, cryptocurrency bot. So it has very huge number of tutorials, even examples for that. So I'm very much interested in gaming, mostly how game works behind the scene. Okay, so build your own game. Let's just do that. Chess engine, C. These are for C, C++, C Sharp, Java. Oh my God. Handmade hero. Join our mailing list for project updates. Computer enhance. So secret game project. If you are a portfolio manager seeking a one of a kind game, please contact us. Programming demos available for prospective platform partners. Okay, this is something I right now I'm not interested in. Where did it go? Where was I? It has redirected to me somewhere. Okay. So if you want to learn like physics engine is also for gaming. Okay, neural network, neural stack. Why is it not how to make how to program a NES game in C, Python, Rust. I'm good with develop game with Py. Yeah, I already have created one game using Python. Let's just check this out. So this is a repository where you can find the resources. Okay, these are different resources you can find in here, and build your own X. So build your own Docker C containers, 100 line, yes, 500 lines of code. So how a container engine works, it will show you like that. So this will for gathering data, resources, and everything. So you can find it over here. Okay, build your own X. You can create your project. Basically, whenever you start something, it is it is not what you learn. Okay, it is always what you do. So learning is one part. You can accumulate a lot of knowledge, accumulate everything. You have tons of resources. You have tons of YouTube channels. Okay, but if you don't do anything, then you can't uh, you can't move ahead. Okay, build your own database. So this will sharpen your concept of what is indexing and what are there in database. Indexing, caching. Then there is I also forget about all these since I'm in mostly in using and implementation usage and implementation part, and this particular repo first contribution. So you can directly use it, fork this repo, clone this repository, make the changes, create a branch, create your branch, and at contributors.md they have everything. Push the changes, submit your changes, pull request. So all these things, if whenever you go to an enterprise, so all these steps you have to do yourself. Okay, so this is a very great place also to check for some repository, and there are some more let me check. There are build your own X is one of the repo. Then awesome for beginners, yeah, this one, awesome for beginners. Okay, first PR opportunity. So it is an open source repo. You can anytime use. So .NET, Scala, Python, Go, okay, Ruby, all the languages they have. Good first issue. Ansible is a very popular tool. So Ansible, it is based on Python, It is an open source configuration management tool. We'll understand more about it in our journey. Then there are SaltStack, PyTorch. These are some of the great open source repositories. Okay. Then Jarvis, Matplotlib. I think Plotly is also in here. PyTest, it is testing framework. PyTorch. Then Scrapy, Scikit-learn for data science and other. Okay. So they have a lot of open source repositories. You just have to check it out. Okay. I wouldn't say just start committing to these repositories, but first of all, we already have discussed about FreeCodeCamp. Okay, FreeCodeCamp is a great place to start your journey. FreeCodeCamp open source contribution. Okay, how to make your first open source contribution. So there are a lot of articles. Read it and implement it. Okay, read it, implement it, get failed, get errors, and that's how you learn. Okay, just you see, okay, I have this particular article, I don't even bother to read it, then I'm not going to learn anything. Okay, I'm not going to learn. So learning is a process that you have to follow step by step, first by eyes, then by hands, and that's how you learn. Okay, so step one, fork your repository. They have everything. FreeCodeCamp, if you are an aspiring developer, just go to their freecodecamp.org and start learning. Okay, I would suggest you, yes, contribute to FreeCodeCamp community. Get started. How would you how would you contribute? So FreeCodeCamp is a website that hosts all the free certifications and everything. They have around 300 hours of courses available. Okay, so you can just check them out and start your learning journey over there. Get started for free, and it is absolutely free, nothing much. So alumni say about FreeCodeCamp. So start any of the journey like responsive web design certification. These are all the free certifications, and they have tons of any certification. If you don't have the skills but have the certification doesn't have the value. Okay, it is the skills that matter. Any certification, any degree, any diploma, it doesn't matter. It only thing that matters is the skills. Okay, so just start doing it. Legacy Python for everyone. Legacy responsive. So these are some old JavaScript algorithms and data structure certification. So these are some of the old courses that they have provided. Odin project, remix beta. You can anywhere check over here. Then scientific computing. So just get started for free. Click here. I think I already have an account, so I'll just stop here. So yeah, this is for Git and GitHub. Let's reconvene tomorrow. And thanks for all your support. And yeah, let's continue in our journey. Thank you all.